Good morning, students. Again, this is Mr. Lopez saying hello. We're looking at 16.3 Group D problem solving. I want to say hello to everyone out there. Hello, Jabril. Hello, Mr. Lowe, Ayan, Lena, Mariam, Zehna. I'm just going down and visually trying to remember everyone's seating arrangement. Isa, good morning. Hope I didn't leave anybody out. I'm trying to just visualize. Good morning, Ramen. Trying to visualize everyone that's in the groups, and I will try to make a checklist. I know I'm missing some, but I'm just going through the top of my head. Let me see. Let me go down the row here mentally. Hello, Ayan. Hello, Jabril. Hello, Zehna. Going down. Isa, hello. Hello, Mr. Lowe. Going up. I don't see anybody there. Let me see. Let me go through my mental in the middle of the class. Is there anyone? No, I already went to Ramen. No, I'm leaving somebody out. I said hello, Miriam, to Lena, and I will double check. I want to wish everyone a happy day today. Thank you for your patience, and I hope this is helping. I know it's a little bit difficult since I'm not there live with you, having to interacting, answering questions. Who understands? Who doesn't? We have to make the best of it, and I hope it's going well. I have spoken to some of your parents, and I know there's an issue of being able to apply the guided practice to the daily task assessment and the homework. And again, go back, replay the video, and see what areas you're missing or that don't make sense. Go and look at the videos on YouTube. I mean, not on YouTube, I'm sorry. Go Math. Go Math has the those videos that I showed you how to search for. So, again, if you have questions, send me an email, and we'll try to address them. Hopefully, in the future, we'll be having the live streaming. Well, I'll be able to see everyone's faces on my computer screen, and we'll be able to have a live instruction, like in the classroom, but remotely. So hopefully, that's in the future. So let's look at 16.3. You should have a pencil and a highlighter, a colored pencil, something handy to help you work out these problems. We're going to be looking at areas of rectangles, and we're going to be looking at different patterns to help us analyze the areas of different rectangles. So before we start, let's clarify one thing right now. Let's clarify the length and width of a rectangle. So remember length, and I apologize for this as the pin's not here yet, and equals A. This is the formula you'll be seeing. So for this case, we're going to look at this area here as the length, this area here as the width for this rectangle for this lesson. So it's length and then the width. So again, length, width, and when we multiply those two, that gives us the area. So let's look at this. Let's fill out this section right here. Let's read the rectangle. Show Mr. Coy's plans for storage sheds, and how are the sheds, the areas of the sheds related. That's what we're going to be looking. The area of this shed compared to the area of this shed, the area of shed C and the area of shed D. We're going to use a little graphic organizer to help us organize our thoughts. And what we're doing right now is what you're going to be doing next with the additional questions that follow from here. So just follow along with me. So let's look at our graphic organizer here. Make that a little bit smaller. A little bit too small. So I need to find how the areas will change from A to B and fill this in. What information am I given? I'm given the what? You're given the and the good. I will record the areas in the table, then I will look for patterns to show the blank how the blank will change. So go ahead and fill these out and let's see how you did. This section we're doing this. So in this case, you're looking at what? We're just referring to this. So I need to find the areas, how the areas will change from A to B, and this should be C to D. I am giving the length and the width of each shed to find the area. I will record the areas in a table, then I will look for a pattern to see how the areas will change. So I think I did another one here for you. Oops. this ready for you. Sorry. There it is. I was working on it a while ago. So again, to check your work, C and D, length and area. Now let's look at the next section here. So, shed A. Let's make it smaller. Shed A. And we're looking at this. We're going to fill this in. So I'll guide you through this. And again, be patient. And everything, we're going to get the information from here. We're going to fill this in, and we're going to start seeing a pattern emerge here. So we have the length for shed A is 3, and the width is what? It's 4. Fill that in. So the area here is what? 12. Good. For shed B, they're giving us the length is 3 feet, and the width is what? The width is 8 feet. And it's very hard to write with this pen. Using the mouse, I'm sorry. So 3 times 8, and this number is 24. And again, I'm getting everything from here. Shed C, the length is what? The length is what? That's 6 feet. The width is 4. And the area is 24. The next one, the length is what? 6 feet. And the width is 8. And your answer is 48. So let's look at the pattern here. You should see a pattern emerge right now. So the areas change from blank to blank, and from blank to blank, and I see the lengths will be the same. So the areas change from what? Okay, fill this section out. Let me erase that for you. So we'll look at this right here. So the areas change from 12 square feet here to 24 square feet here. And from 24 square feet here to 48 square feet. Okay? So all we're doing, the areas change. We're looking at this one, comparing these two, from 12 to 24, and from 24 to 48. So what do you see between these two areas? What do you see between these two areas? So when the lengths are the same here, and the widths are doubled, see how this one's doubled? The areas will be doubled. Notice how 24 is double 12. Okay? Does that make sense? So the areas change from 12 square feet to 24 square feet here, from 24 square feet here to 48. So when the lengths are the same and the widths are double, so when the lengths are the same, okay, and the widths are doubled, okay, notice the lengths are the same here, the widths are doubled, the areas will be doubled. So here we have the lengths the same, the widths are doubled, so your areas will be doubled. That's the concept we want to get out of this. So if you look at the next section here, it's the exact same thing we did on the one above. So go ahead and pause the video right now. Try another one to work this out. It's the exact same thing we did. Okay, we're going to go look at each one now. You're going to fill all this in, and refer back to this one. Refer back to what we did earlier. It's the exact same activity. Exactly the same. Okay, now you're just going to put it into practice. So go ahead and pause it now. Complete it, and then we'll just see how you did. Okay, welcome back. So we're looking at the try another problem, and let's see how it worked. So we're looking at this section here. Sorry. So we have the two sheds, E and F, and then the other two sheds, G and H. We're giving the length, we're giving the width. So look at the length for these two. Look at the width. And compare those. So what are you going to fill in here? You need to find out. You need to find out how the areas change from E to F and G to H. Good. And what information are you giving? You're giving the length and width of each shed. And what is your strategy? You're going to use this table to record the areas in the table. And then you're going to look for a pattern. So let's see how you filled out the table. And again, we're getting the information straight off from this. So all you have to do is refer to this. So length. So E has the length of 5 feet and a width of 8 feet. F has the length of 5 feet and a width of 4 feet. And then the pattern emerges. So E has the length of 5 feet and the width of 8 feet. And the area is 40 because 5 times 8 is 40. Shed F has the length of 5 feet and the width of 4 feet. And the area is 20. So what happened here? The width was reduced by half. So when the length is the same, but the width is cut in half, the area will also be in half. So notice this is half, 20 is half of 40. The same thing emerged here. Length is the same. The widths are all halved. So you look at this area of shed G, area is 80. The width was half from the next shed, so your areas, the pattern for the areas will be changed to halves. And this is what I typed out for you. The lengths will be the same, and the lengths will be the same, and the widths will be half. Lengths will be the same, the widths will be half. The areas will change from 40 square feet to 20, and from 80 square feet to 40. So when the lengths are the same and the widths are halved, the areas will be halved. So when the lengths are the same and the widths are halved, the areas will be halved also. But the key is to know this, that the lengths are the same. It's the width that's being halved. And how did the table help you find the pattern? Well, a possible answer, you were able to see the multiplication of the length times width to get the areas for the sheds, and you were able to see how the pattern emerged. The question for this one, what if both lengths and widths of the sheds are double? So now they're going to double both the length and the width. What's going to happen to the area? Well, if it's doubled, how would it change? The area will be doubled twice, or it'd be 4 times greater. So if this is doubled and this is doubled, this will be 4 times greater. So it will be doubled twice. So again, and that pattern will continue if you continue to double the areas, the lengths, and the widths. Okay, I hope that was understandable there. Okay, we're going to go to share and show. Go ahead and do number 1 and 2. And if you can, well, let's do 1 and 2 first. So many swimming pools are built in rectangular shapes. How do the areas of the pools in the table change when the lengths are changed? So they all have the same width. The only thing that changes is the length. So what would you do here? You'll multiply these two. So multiply these two, get your answers here, and then start looking for the pattern. And then answer this. What if the width of each pool was 4 feet? What if this was 4 feet? This was halved. What's going to happen to the area? So remember, go back to see what we did earlier. So they're asking you first for the pattern, what's happening here. Once you get your multiplication, you should see the pattern emerging here between the areas. So what's staying the same? Okay? And what's happening to the lengths? Look at the pattern. Okay? And then fill this in. Let's see how you did. So go ahead and pause it, fill that in. Okay, welcome back. And let's take a look at. So when you work this out and multiply it 8 times 20, these are your answers here. These are your products. Okay. So the widths here are the same. Right? The lengths here, yes, they all increase by 10. 10, 20, 30, 40. Okay. Okay, and the areas here all increase by what? Well, if you looked at the pattern, each one looks, it's 80 square feet. 160 plus 80 is 240, 240 plus 80 is 320, 320 plus 80 is 400. So that's what I wanted you to see there. And if you just subtract this from this, you should have got the 80. So going back to this one, what if the widths of each pool were 4 feet? What if this was halved? Okay, now you will multiply the length, 4 times 20, that'd be 80. The areas were half when they were, the areas were half what they were when you multiply by 8. So this was half when you multiply this by 8. Of course, because you put this half. You have this with a 4. This was a 4 now. So this, of course, had to get halved. Okay, so when if you put a 4 here for the width, 4 times 20 is 80. That's half of 160. Put a 4 here, 4 times 30 is 120. That's half of 240 and so forth. So again, look at the pattern. So when this gets halved, the area gets halved. That's the concept I wanted to see for you to get here. So let's look at the next one here. Oops. Elizabeth built a sandbox that is 4 feet long and 4 feet wide. So get that visual of the area here. She also built a flower garden that's 4 feet long and 6 feet wide. She built a vegetable garden that is 4 feet long and 8 feet wide. Explain how the areas change. So what are your products looking like here? What is staying the same? Very good, Zahana. Thank you for raising your hand. Very good, Mr. Lowe. Very good. Ayan, very good. Yes, the width, the length is staying the same. Okay? The length is staying the same. So the width, 4 feet long, 4 feet wide, 4 feet long, 6 feet wide, 4 feet long, 8 feet wide. See what happens here. Okay, the areas are all 6. The area of the sandbox is 16. This one, because 4 times 4 is 16. The area of the flower garden is 24. Why? Because 4 times 6 is 24. And the vegetable garden is what? 32. So the lengths are staying the same here, but the areas increase by 8 feet. So when you got your areas here for each one of these, so look, 16, 24, 32, they all increase by 8. But you have to work it out. You're not going to be able to see the pattern if you're trying to do it in your head. It's going to be very difficult. That's why you need to work this out. Okay, Jacob has a rectangular garden with an area of 56 square feet. The length of the garden is 8 feet. Again, that's your sentence right there. 56 divided by 8 is what? 7 feet. What is the width of it? That's the only thing that you're going to have there. I'm sorry. Let me look at that. So you have, I was thinking of the other groups. I'm sorry. So just draw the picture here. Jacob has a rectangular garden with the area of 50. You know the area is 56. So area equals 56. And what do they give you? They always give you what you're going to need. I'm sorry for that. 56. What is the width? The length is what? The length is 8. And this is what you're trying to solve. And 8 times what gives you 56? And the answer is 7. Okay. So again, draw the picture. Length and width. Okay. I hope that helps. I really miss everyone. Seeing everyone in class. I know this is a lot easier when we're in class and I'm able to stop, look at what you're working, answer some of the questions, and I could see, walk around and see how you work these out in your workbooks. But for now, this is the best we can do for now until we get the live streaming. What you have next to do is your daily task assessments and your homework. We will check this the following day. You do have an online Think Central assignment today related to this section. And again, I hope everyone is doing well. I know it's a difficult time right now, but this too shall pass. I look forward to seeing everyone online sooner than later. So for now, this is Mr. Lopez wishing everyone a happy day today. Make sure you take some time and thank your parents for everything that they do for you. And for now, if you have any questions, go back, review the video, replay it. Go to Think Central. If you go to your dashboard, you can find those module videos, find this section, and find the section dealing with 16.3, and you'll have another video in there that can help you if this one if you still need some extra help with that. So hopefully, oops, I'm sorry. So the next thing you do is your daily task assessments and to read the questions and start looking at the patterns. It's the same thing we did today. Fill this out, and you'll be successful. Trust me. Once you play with it, the patterns will start emerging. And please don't feel stressed and worried about if you're making errors. It's okay to make an error. We're doing this in a different way, and these kind of things will happen. So long as you practice, that's what we're more concerned about. So this is Mr. Lopez signing off, and we'll talk to you later. Goodbye.